right, so the last thing that we're going to look at in section 12.1 are misuses of statistics. So statistics, when used properly, is a valuable tool to society. However, many individuals, businesses, and advertising firms misuse statistics to their own advantage. You should examine statistical statements and or graphs very carefully before accepting them as fact. You should ask yourself these questions, among others. Was a sample used to gather the statistical data unbiased and of sufficient size? Is the statistical statement ambiguous? Could it be interpreted in more than one way? Is the graph drawn in a way that is misleading? In other words, we could be using a different scale or adding to more than 100% or something along those lines. Right, so in this example, we're going to discuss some different possible misuses of statistics. So 4 out of 5 dentists recommend sugarless gum for their patients who chew gum. So one possible misuse or misinterpretation that may exist, so we could list a few different things here. Our sample size is unknown. Right? If our sample size is only 5 dentists, it's probably not a representative sample of our entire population. The question to how they obtained this data is unknown. Right? And the actual data used to back up the claim is also unknown. Right, so there's too many unknown things in this particular example to make it a good statistical statement. Right, for example B, the average salary of company A's employees is $45,000 and the average employee's salary for company B is $40,000. Therefore, company A is better than company B. This would be an example of somewhat of an ambiguous statement. Right? There can be many different interpretations of the word average. Which we are going to talk about in just a little bit in one of the next couple of sections. Whether we're talking about mean or median or mode or something along those lines, they all have very different meanings in context. So as far as using the word average, it's not necessarily a good way of comparing two different things when we don't know a lot of other information about this. Right, for C, a department store claims it is the largest department store in the United States. Therefore, this department store is the best. Largest, right, is another vague or ambiguous word. What do we mean by largest? Have the most stores, have the most employees, have the largest square footage of area in the United States. It could mean a bunch of different things. So largest is another vague or ambiguous word. So largest doesn't necessarily equate to best. Right. Company C claims that its paper towels are heavier than its competition's towels. Therefore, they will hold more water. However, we don't necessarily know that weight is a measure of absorbency. So, is weight a good measure of absorbency? So we could come up with kind of a crazy off-the-wall conclusion if we compared a rock or a sponge. Right, a rock is definitely heavier than a sponge, but a sponge is definitely much more absorbent. So as far as kind of what we're using here, we don't necessarily know that weight is a good measure of absorbency, and we will say irrelevant conclusions such as Right, rock versus sponge. Right, and then for E, both bar charts report the same data. Y is the first image below misleading. And I know this picture is kind of tiny, but if we look at these in very little print, in this particular case, this axis starts at 1.20 and goes up to 1.40, where this one starts at 0 and this one starts at 1.4. So in this particular case, we could say that inappropriate scaling where it does not start at 0 causes a more dramatic appearance. So inappropriate scales, again, graphs that somehow add up to more than 100%, anything along those lines that could cause any sort of question, right, are also ways that statistics can be misused.